Okay, 9 a.m. Thanks for joining us, everybody. Welcome to the session on photometric redshifts for LSST objects in the annual data releases. I'm going to tell you what those terms mean in a moment. Let's start with our friendly, there's a mob on me. Start with our friendly reminders that this workshop has a code of conduct that we all abide by. If you witness or experience any violations of the code of conduct like bullying, harassment, or aggression, just go to the project and community workshop website. There's a code of conduct page, and it will have contact information for our workplace culture advocates that you can contact to report the incident. Other friendly reminders is that all talks at this workshop will be recorded, videos will be posted the next working day. And as we use the Slack chat for questions and stuff, please give thumbs up to questions if you have the same question, sort of like upvote a question so that we can raise it in the session. And then when speakers finish, to show your appreciation using the Zoom reactions, such as the applause function. So in today's session, we're going to sort of go over or give you an introduction to the data management's photometric redshifts roadmap. And I'm going to tell you all about that first, including our letters of recommendation, our open call for letters of recommendation, and then tell you a little bit about what's going to happen during the commissioning phase when we need to validate the PhotoZ. Now there'll be a Q&A period for that. And then we have with us today Julia and Alex, who will each be giving talks about different types of PhotoZ infrastructure that we are looking at using for the commissioning period, and which are being used for like other things as well, and then how they might fit in with commissioning for data management PhotoZ. So we'll have those two talks as well. Should be a good session today. Let's get started. So just for some context, I wanted to review this summary of the data release data products, where data release is often shortened to just DR. So the DR always stands for a data release. The data release contents will be both images and catalogs. These are the data releases are the data products that are released annually. And you can see the data release timescale here with DR1, including all of the data from the first half year of the survey, DR2 from the first year, and then so on an annual basis up to DR11. I will add a little asterisk there that I believe there's a proposal on the table to change the wording so that DR1 corresponds to year 1 and so on, to make it a little more understandable. Each of these data releases, no matter what they're named, will have both images and catalogs, where the images will include the processed visit images, so like the single image and a single filter at a certain time, and then the deep co-added stacks of all of the images for the survey to date. The catalogs will include both sources and objects, where I've got a little definitions window down here in the bottom right, where a source is a single detection in a single image, and an object are sources associated by their location / coordinates. The catalogs will also include the results of difference image analysis, so DIA sources and DIA objects, as well as forced sources, which is force photometry. So the source measurements include such things like the PSF, the shape, the size, and the flux. And then there's also catalogs for object characterization for things like color, model fits, variability of the object, and then things like photometric redshifts, which is the topic of today. So when we say the LSST object PhotoZ for the data release, we mean the PhotoZ that is in the object catalog and released as part of an annual data release. So that should bring you sort of up to speed on the sort of the nomenclature and what it is that we're talking about. So making PhotoZ for all the objects in an LSST data release, that's something that the data management system, the DMS, is required to compute. And that requirement is documented in LSST/LSC 61. But it's not a trivial task at all. And it's really the science community that has the wealth of expertise in generating photometric redshifts, and it's the science community that will be the primary users of this data product. So the data management team wants to involve the science community in selecting, implementing, and validating one or possibly more PhotoZ estimators to produce the photometric redshifts for the LSST object catalog. And I say one or more because with compression, we might be able to store the results of more than one PZ estimator in the object catalog, sort of on a to be determined basis. So making them in the first place is challenging. Involving the diverse science community in the process is also very complicated, and this requires a lot of communication and coordination. And so we, the data management team, I forgot to introduce myself again, I always do. My name is Melissa Graham and I work at the University of Washington, and I work on the data management team as a science analyst. And photometric redshifts are one of the things that I've been working on for the data management team. Just one second. Okay. Sorry, I was distracted for a second. Right, so this process is very complicated, and so the data management team has developed a roadmap for photometric redshifts that will be our framework and our guide over the next couple of years as we work towards this common goal. And I do want to point out the fact here that I'm using this term science community, and by that term I just mean everyone interested in LSST PhotoZ. That includes members of the science collaborations and of the international programs who are proposing in-kind contributions related to LSST PhotoZ, and just anyone who plans to use LSST PhotoZ as part of their LSST research in the future. So this roadmap that data management has developed, this just kind of gives you a really brief overview of what's in there. You can find the full roadmap at ls.st/dmtn049, where DMTN stands for Data Management Tech Note. So you can find the full thing online, but basically it's got a timeline in there, a full section on the technical considerations for what kinds of PhotoZ estimators could be implemented into the data management system. It's got a section on how you evaluate, or how we plan to evaluate, different PhotoZ estimators when making this choice. And then it introduces the letters of recommendation process that I'm about to tell you about, and has a section sort of saved to describe what will happen with the commissioning data and how the commissioning process will go over the next couple of years. So the full thing is there, but what I really wanted to tell you about is the letters of recommendation process and give you a little bit of context for the timeline. So we kind of started this roadmap earlier this year in February through April by hosting sort of a set of just open forums where people could come and talk about the PhotoZ and the work that they wanted to do with it. And that really helped us to develop the roadmap itself. In May of this year, we sort of introduced the concept of a letter of recommendation and made the formal call for it, which I will show you soon. And then we have been hosting another set of monthly PhotoZ virtual forums, just as places where people can come talk about PhotoZ, ask questions about the roadmap and the letters of recommendation. These letters will be due at the end of September. And then the timeline that happens after that is sort of between the accepting the letters of recommendation and commissioning starting. The data management team will review all of the letters and try to make like a short list of PhotoZ estimators that seem like they're going to be good contenders and really useful for producing the LSST object PhotoZ. And then, of course, during commissioning, data management plans to facilitate community participation in the evaluation and validation of these shortlisted PZ estimators using commissioning data. That's a little bit TBD exactly what that looks like right now. So these letters of recommendation, the purpose of having them is to give the community a formal opportunity to state their scientific needs for LSST object PhotoZ. The writers of these letters, it's really anyone who would use the object PhotoZ for their LSST research, or developers of PhotoZ algorithms who think they've developed something that could be quite useful for PhotoZ, and they want their algorithm or their estimator to be considered as one of the ones to generate the LSST object PhotoZ. The scope of these letters I want to emphasize is that they are quite short and very qualitative. So this isn't meant to be like a big evaluation of different estimators to like prove which one would work best for you. That's not what these letters are. They should be quite short. They just should describe either the kinds of science that you would want to do with the object photo Z to give us an idea of like what it is you need from this data product. Or you could define sort of a minimum science-driven requirements for the object photo Z. So like the lowest level of quality for a photo Z that it could have and like still be useful for you. Or your letter might simply recommend a certain photo Z estimator be used because it's worked well for you in the past, or it's something you're developing, that kind of thing. So pretty small in terms of scope. The data management team will take in all of these letters and look at them and then create a short list of community vetted photo Z estimators to use as a starting point for the commissioning phase. And they'll be due in September 30th, on September 30th of this year. And I just want to show you the template just to further emphasize how short they are. So the letters just have 4 main components, and not all of them would be applicable to all situations, like to all letter writers. I think the first one, the scientific utility, is the one that all letters would probably contain, and that's where you describe your photo Z related science or how the estimator that you're recommending would enable science, depending on the type of letter you're writing. The second one, we do want to hear about outputs. So if it's something that you know about, describe the minimum set of photo Z outputs that are required for your science, or describe the outputs generated by the photo Z estimator you're recommending. If it's possible, do describe the minimum photo Z quality that would enable your photo Z related science, or the minimum quality of the photo Z estimator you are recommending. So we're really looking to sort of set the lower bar of what is going to be useful in terms of the photo Z data product here, not like the cutting edge science stuff. We're looking for something that's got general utility, broad applicability, and sort of hits a minimum level in terms of quality. And then the fourth one is probably only applicable if you're writing a letter from the perspective of a photo Z estimator developer. And in this fourth one, please address the technical considerations that are in the data management tech notes, so things like amount of storage space, amount of processing time, that kind of thing. But that might not be applicable to all letters. So you can find the call for the letters of recommendation and 2 examples of letters, one from the perspective of advocating for an estimator and one from the perspective of a scientist who will need to use this data product in the future. You can find them all on the community forum at community.lsst.org. In the science category, there's a subcategory called Photometric Redshifts, and that's where you will find these topics to sort of guide your LOR writing. And then looking beyond these letters of recommendations. So later this year, the data management team is going to consider all of these letters, create a short list and publish it as part of section 5 of the Photo Z roadmap in DMTN 049. At that time, we'll also be clarifying the plans for commissioning by updating section 6 of the PZ roadmap, and then we'll be advertising these updates pretty broadly. So you'll see posts on community and emails to the mailing lists and posts on Slack and stuff like that about these updates. And then I wanted to say a couple things about what will happen during commissioning, even though it's still sort of a to be determined exactly how this will go. But data management does plan to support scientists as they evaluate and validate the PZ estimators using commissioning data. Right now, we're sort of referring to this commissioning phase, as the Photo Z Validation Cooperative, because we think there's going to be a lot of different people from different perspectives sort of all participating in this effort at different levels and all cooperating together to try and sort of get us to a state where data management can provide and generate a Photo Z that will be broadly useful to many LSST scientists. So as I mentioned, the details for commissioning phase are still being determined, but as you've heard over the course of this week, there is a commissioning announcement of opportunity to dedicate effort to the commissioning team and in return have access to the unreleased commissioning data. So we do envision some of the people who want to participate in this PhotoZ Validation Cooperative actually joining the commissioning team and using the unreleased commissioning data to try to get like an early start on doing some PhotoZ validation, and also using, whenever you try to derive a scientific data product from data, that can really be helpful for the commissioning effort itself. That can tell you things about the data. So we envision there will be a few scientists sort of joining the commissioning team in that capacity and doing PhotoZ related things with the unreleased data. But we also expect that many, many more scientists will simply be using the released commissioning data that comes out as part of the data previews to participate in the validation process. And as a final side note, data rights will be required to access the commissioning data and the data previews, of course. That's not a surprise. So I think that's everything I wanted to tell you sort of about the roadmap and the letters of recommendation. And I'm going to just pause here. I can't see the Slack channel, so if there have been questions in the Slack, maybe Julia or Alex could raise those for us. And I don't see any questions in the Zoom chat yet, but feel free to put a question about letters of recommendation in Zoom chat, or use the raise your hand feature in Zoom.
Yeah, for now we don't have questions, just a few comments about the name of data release based on the years.
Oh, okay, yeah.
But
okay.
No questions.
Okay, I'm just gonna like count to 15 in my head and see if any questions come up. Oh, one hand up from Connect. Go ahead and unmute.
Hi, I'm Kanak, and I joined a bit late. So I was wondering, in the PhotoZ estimation, are you going to use only the LSST bands, or there will be multi-band to be used for the PhotoZ estimation?
Yes, the LSST object PhotoZ that will be in the data release will only be based on LSST data.
Okay, and is there already a preferred method for estimating the PhotoZ, like some standard CD fittings routine?
Not yet. That's really what we're trying to evaluate with the letters of recommendation process, is just hearing from people on the types of PhotoZ estimators that they need, what kind of data products they need, like you can do whether they need you know, the SED fits as well, if just a PhotoZ is good for their science. Sometimes you can get extra galaxy properties out of your PhotoZ estimator, so that's a good thing to know as well. So nothing is really set yet. That's what we're looking to find out with the letters.
Okay, great, thanks. Yeah.
Thanks, Kanan.
There is a question from Harry Ferguson. The construction of PhotoZs may be a bit distinct from the estimators. Can you talk a bit about the roadmap, thoughts on generating PDFs or developing techniques to do that?
Yes, I think I can. I mean, I could say that the LSST object catalog has about 200 floats reserved so that we can store the full PDF if necessary, or the compressed versions of PDFs, like the posteriors from multiple estimators. I'm not sure that that was quite the question.
Yeah, so let me unmute. So
Yeah.
it's a little bit of people, in the sense that it may be that there are people who are well geared up to try different ways to validate the probability distributions, e.g. based on clustering or based on redshifts or whatever. And so it might actually not be the group that's developing the estimator that's best placed to validate it with ground zero tests.
I'm sorry, I still missed the question.
Well, you know, first of all, the estimators might just give you a point estimate, or they might give you a PDF, but you would like to validate that PDF somehow. And there are, you know, different ways to try to validate that. And I'm just thinking that the people who have ways to do that might not be the same people who develop the estimators. And I don't know if you're necessarily going to get input on that in the letters of recommendation if you haven't asked for it. And it's like sort of key to figuring out if you have good photometric redshifts.
Yes, I mean, the letters of recommendation process is really just supposed to be 0th level, very qualitative. I think the kinds of things you're thinking about are more what we plan to do in the commissioning phase, where people will actually start using them and thinking about how to validate them. Yeah. Yeah, so yeah, we don't expect that in the letters at all. Letters are pretty simple. You just want a broad net of understanding what people need in terms of PhotoZ data products. Yeah. Yeah, thanks, Ari.
Do you have time for more questions? We have a couple of.
No, I'll go in the Slack while you're giving your presentation, and I'll see what else I can answer. But Julia, otherwise, I'm going to turn it over to you now.
Okay.
You should be able to screen share.
All right, can you see my slide?
Yes.
Okay, hi everyone. My name is Julia Xuven. I work at Linea, and I'm going to give you some highlights of Linea's in-kind contributions to Rubin PhotoZ. So Linea is an institution in Brazil that provides services for the astronomical community. And we proposed a variety of in-kind contributions to Rubin. And in this session, I'm going to share with you our plans for those related to PhotoZ. In other words, for those that have Rubin PhotoZ coordination group as the primary recipient group. So they are standardized training and validation sets, and the pipeline used to create it. A PhotoZ server, a data management tool to facilitate sharing results among the Rubin Science Platform users, and PhotoZ tables as federated data sets in the Brazilian IDEC, in addition to the official project's PhotoZs for each data release. And in the next slides, I will give you more details about these two first items. The third one is pretty straightforward, not the implementation, but the concept is simple. Just Linea is planning to run at least one PhotoZ algorithm for the whole LSST objects catalog for every data release. And it's not the one chosen to be part of the official data release, but a second or third option of PhotoZ algorithm to be defined by Rubin and to be available for the whole LSST community as a federated data set hosted in the Brazilian IDEC. So I'll start with a big caveat. What I'm going to show is still in the design phase. So these are preliminary plans yet to be discussed with the Rubin team before starting the actual development. And the goal of the presentation is to let you know about what is being planned to provide useful data management tools to handle PhotoZ related data products. So please consider the following details as we are raising requirements, and please don't be attached to any methodology in case I mention some. And if you were in yesterday's IDEC breakout session, you should be aware that a lot of technical aspects of the IDEX are still under discussion. So these initial plans are most of them based on our previous experience collaborating with the Dark Energy Survey. And also based on conversations with the recipient group when preparing the proposal. So the first contribution is a new pipeline inspired in the DEA Science Portal's training set maker, but to be implemented using a Jupyter notebook as a front end. So these gray boxes refer to the 4 tasks carried out by this pipeline, and the blue box represent the PhotoZ server, which I'm going to describe in a moment. It starts with retrieving spectroscopic redshift tables from public data sets available. And this is a screenshot of the DES Science Portal pipeline where the user chooses which spectroscopic survey will be included in the training set. For the new pipeline, we are going to develop it using Jupyter Notebook. So we are probably going to use IPy widgets to build these menus. And that's the second step is the first round of data preparation after combining data from several different sources. So there is an internal cross-match to identify multiple measurements for the same objects, and the user chooses how to handle it, which measurements to include in the training set. And another feature is to translate quality flags to a standard flag system, because each spectroscopic survey has its own quality flag system. And in DES, the combined sample preserves the original flags, but also includes an additional flags that translate them all to a standard flag system. And regular updates are expected, and they are included in the in-kind contributions proposal. They include, for instance, adding new surveys on the list of inputs as new data become available, and consequently including their flags transformation. And so the next step is the spatial matching between spectroscopic and photometric data, and this is the most data-intensive part of the pipeline. And finally, the last step is the separation of the matched sample into two samples for training and validation. And there are many ways to do that. For example, it can be a simple random selection, or it can be selecting training objects according to a given theoretical distribution, or applying weights based on photometric set characteristics, or using data augmentation to improve photometric set representativity, or even selecting a particular spectroscopic survey as validation set, or any other science-driven choice you can imagine. So we plan to provide one implementation to be defined by Rubin, but we would invite and encourage the community to contribute by adding their specific science-driven methods for subsampling the separation, the subsample separation. So the code will be flexible and available on GitHub for anyone to contribute. And the pipeline should be available for users with data rights to create their customized training and validation sets. But Rubin's PhotoZ coordination group will define the parameters for the one to be considered standard and to be used in the PhotoZ Validation Cooperative. This particular product should be easily accessed by the whole community via the Rubin Science Platform. Which leads us to the second in-kind contribution, the PhotoZ server. So again, this is all preliminary. The general concept of these contributions are already approved by the in-kind contribution committee, but implementation details are yet to be approved by Rubin PhotoZ coordination group. So there is a brief mention to the PhotoZ server in the data management roadmap document that Melissa just mentioned. And the main motivation is to help on the administrative side of these collaborative initiatives like the PhotoZ coordination, the PhotoZ Validation Cooperative. And we will do that by maintaining a small administrative database to handle all the relevant metadata. So we predict two main types of PhotoZ related data products. The first is the matched catalogs, that is the training and validation samples. And for this type, some relevant metadata are, for example, which spectroscopic surveys were included, and which release of LSST photometric data were used, which duplicates removal criteria, which subsample separation criteria, executed by whom, when, and etc. And the second type of data products would be the output of PhotoZ algorithms for the validation samples, those described in section 4.2 of the roadmap document. And some examples of relevant metadata would be which code, which PhotoZ code, which version of the code, executed by whom, when, and which configuration parameters, which data sets were used as input, and etc. And so the front end would be inspired in the Dataverse, which I'm going to show in a moment. And it should be, this administrative database should be hosted in the Brazilian IDEC, but connected to the Rubin Science Platform through the API aspect. So the Photosys server will have a very simple interface with 2 pages, one for uploading the data and another one for accessing the relevant information and also to download. The upload tool will be an interface with fields to fill in with the relevant metadata. Here I'm showing a screenshot of the DES Science Portal upload tool just as an illustration, but the fields to fill in would be different, would be those related to the Photosys data products. And there is also this drag and drop tool, very cool, to associate the column names to standard names expected by the system. And it's particularly useful when you're adding external data sets with different column names. And after the upload, the data products become available for download in a list of products. And this is an example of the DES Science Portal dashboard, where we have all the products listed. And there is a button here to download and several other buttons to have access to the metadata. And most recently, we implemented the Dataverse, which is the tool used to distribute data products that are results of scientific publications. And it's another example of front end to provide access to the metadata and to download. So you have here a tab with access to metadata, and here the buttons for download. But the idea is to have the download as optional. So the metadata would include instructions on how to access these data products directly from Rubin Science Platform notebook aspect, so that the download is not necessary. So I conclude my presentation here with a quick summary. So Linea teams will work with Rubin Photosys Coordination Group to deliver standardized training and validation sets and the pipeline used to create it, the Photosys server, and also Photosys tables at the Brazilian IDEC. The implementation details are subject of ongoing internal discussions. And this is the timeline established in the approved proposal, but the development work plan should line up with the commissioning timeline. And thank you very much on behalf of Linea team. And now I'm happy to take your questions.
There is one question in the Slack. I'm not sure if you can see your Slack while you're screen sharing.
Yes, from Harry, yeah?
Yeah.
Let me read. Yes, it's about different pieces of metadata that are important, but sometimes different. Yes, we can customize this, the set of metadata, and we also can do that very flexible, like including description text or attached files. So beyond these fields where you put this information, we can have, so like we have here, let me show in the here. We can always have this description tasks or put extra information to be able to include all the complexity of metadata that is necessary.
Yeah, that'd be great. I actually think these ones are so important that they ought to be required for every delivery, because it's, you know, if they're not included, you actually don't know what people have done. So,
Sure, sure. Yeah, and please make suggestions about which kind of metadata is important, because we are in the design phase, so they are more than welcome.